Ever dreamed of having your own robot butler, straight out of a sci-fi movie? Well, today we're going to break down how to turn that dream into a real, totally achievable 16-week project. This is the complete blueprint from zero to a functioning robot helper.
I mean, when you hear robot butler, you probably picture something from a Hollywood blockbuster, a super complex machine that feels decades away. But is that really the case anymore?
The reality is, the tools and the knowledge to build a simple autonomous robot are more accessible today than they have ever been. Seriously, the only thing standing in the way is just having a clear plan. And that's exactly what we have for you. Okay, let's dive into this roadmap. Over the next 4 months, this plan is going to take you from learning the absolute fundamentals to building a virtual robot, teaching it to learn on its own, giving it vision, building its physical body, and then finally programming its very first task. This isn't just a schedule. It's the whole journey, from a single line of code to a functioning helper.
So, the first, and this is the crucial step, it doesn't involve a single screwdriver or circuit board. Nope. Before a robot can exist in the real world, it has to be born in a virtual one. This is where we'll build its brain and teach it the fundamental rules of existence, all safely inside a computer simulation.
So, what's the very first thing we teach this virtual brain? It's this simple yet incredibly powerful loop: sense, decide, and act. The robot uses its virtual sensors to understand its environment, it decides what to do based on its programming, and then it acts on that decision. This is like the fundamental heartbeat of any intelligent machine.
This simple line of Python code you see here, that's essentially the robot's very first thought. It's a basic rule for that decide part of the loop we just talked about. If it senses an obstacle, turn. If not, keep going. It all starts with logic that is this simple.
Now, to test this logic, you need a virtual playground, a simulator. And while there are some highly complex options out there like Gazebo, which are great for advanced research, this blueprint recommends starting with PyBullet. And the reason is simple. It's built for speed and simplicity. That's so crucial when you're starting out because it lets you test ideas fast, fail fast, and learn without getting bogged down. It is the perfect place to build and break your first robot without any real-world consequences.
All right, so once your robot can follow basic commands, it is time to level up. We're moving from telling it exactly what to do in every single situation to teaching it how to actually figure things out on its own.
And that's the million-dollar question, right? I mean, if you had to manually code every single possibility, if the chair is here, turn left. If the cat runs by, stop. The code would become impossibly long. There has to be a better, more efficient way. And there is. It's a concept called reinforcement learning. The easiest way to think about it is like training a puppy. You don't hand it a rule book, right? Instead, you give it a treat for doing something good and a firm no for doing something bad. The robot learns through the same exact process of trial and error, guided by a system of rewards and penalties.
This slide illustrates the concept perfectly. Let's say we want our virtual robot to learn how to find its charging station. We can give it points for success, like +10 for reaching the charger, and take points away from mistakes, like -5 for hitting a wall. By repeatedly trying to maximize its score, the robot eventually teaches itself the most efficient path, all without us ever explicitly programming the route.
So now we have a brain that can navigate and learn. This is where it gets really exciting. It's time to bring our robot out of the simulation and into the physical world. It's time to give it a body, eyes, and legs. So the robot's eyes will be a simple camera, but its ability to actually see and understand, well, that comes from software. We'll use a popular software library, which is really just a collection of pre-written code called OpenCV. With it, we can train the robot to recognize specific objects. It learns to look at a whole mess of pixels and say, aha, that's a bottle.
And the hardware doesn't have to be expensive or complicated at all. This right here is your starter kit. A simple two-wheeled chassis, a little mini computer like a Raspberry Pi to act as the brain, a standard USB camera for the eyes, and a sensor to keep it from bumping into things. That's really all you need to get started.
Now for the grand finale. We have a brain that can learn, a body that can move, and eyes that can see. In this final phase, we're going to combine all of those skills to perform its very first mission as a butler bot.
And here's the mission: autonomous drink delivery. When you summon it, the robot will navigate from where you are to the kitchen. It'll use its new computer vision skills to find the specific bottle you taught it to recognize. And finally, it'll navigate all the way back to you. As you can see, each step in this mission uses a skill we developed in the previous phases. It all comes together.
So let's just zoom out for a moment.
By following this 16-week blueprint, you haven't just built a simple toy. No way. You've actually gone on a complete journey through the fundamentals of modern robotics and artificial intelligence.
I mean, just look at the skills you'd walk away with. You would learn how to program in Python specifically for robotics, train an AI in a virtual environment, implement basic machine learning and computer vision, and finally assemble and control a physical machine. This is an incredibly powerful foundation for anyone interested in this field.
So the blueprint is here. The path from science fiction to a real-world project has been laid out for you. The only question left is the most exciting one of all. What would you want your robot to do?